So now let's see the concept of Wheeler Atherton polygon clipping algorithm in computer graphics. Okay, so the topics I'm going to cover in this video is what exactly the Wheeler Atherton polygon clipping algorithm, and I'll explain the algorithm step by step. So I'll try to explain each step with the help of an explanation, and finally we'll work out with an example. So by using this Wheeler Atherton polygon clipping, how this algorithm is working. The Wheeler Atherton polygon clipping algorithm helps us in clipping of even concave polygons. Okay, the even concave polygons is also possible by using this polygon clipping algorithm. This algorithm clips the concave polygons without leaving any residue behind, unlike Sutherland-Hodgman polygon clipping algorithm. So let me explain you an algorithm, and we will I'll try to explain with an example also. Okay, then you will get complete clarity on what this algorithm is. Okay, so first select all the intersection points. For example, try to select the intersection points like I1, I2, I3 means the polygon and the clipping window. So if the polygon is overlapping on the clipping window, then we need to find the intersection points. So that is I1, I2, whatever the intersection points are there. Make it as an entry or exiting intersection point. So whatever the points that intersection points that are going inside the clipping window, that is entering, and the points that are present outside are the exiting intersection point. From this, make two lists for clipping and clipped polygon. Like means like subject polygon or the clip polygon list. We have to make two lists. One is clipping and another is a clipped polygon. Make sure while filling both lists, the intersection points lies between the correct vertices of each of the polygon. Start to be clipped polygon list. Select the first intersection point, which is named as an entering point, and keep on pushing the points in the list into a vector, and follow the list until an exiting intersection point is found. Then switch the list of the polygon, that is clipping list, and find the exiting the intersection which was encountered previously. So whatever the point that will be started, that end should be also like uh, until that is encountered. Follow the points in this list until the entering intersection point is also found. By pushing all the encountered points into the list, the vector is now become the clipped polygon. And we have to repeat from step to 5, 5 repeat this clipping procedure until the entering intersection points are also visited once. So this is just an algorithm. Now let's try to understand the explanation. What are the points I had explained? Now I am explaining each step with an example. Okay, so whatever I have just explained, that is I just simply reading. Okay, I just read the points. Now I'm explaining each point, each step with an example. Okay, so see here. Okay, so finding all the intersection points and grouping them. Let me take. Okay, so this is what this is clipping window. It's a clipping window. Okay, and what is this? This is a polygon, right? This is a polygon. First step is finding all the intersection points and grouping them. Find the intersection point. This is 1, 2, 3, 4. Okay, 4 intersection points are there. Okay, so that is I naught, I1, I naught, I1 is one intersection point, and I2, I3. Okay, so here I naught is exiting, I1 is entering, I2 is exiting, and I3 is entering. So this is what the step 1. First find the intersection points and grouping them. Now making and filling of two lists. So one is the clipped polygon, another is the clipping window. So the clipped polygon, what is it? So start with vertex V, the intersection point I naught, vertex V, I naught. Next it is coming to W, and next it is going to X. Next it is going to I1 intersection point, and next to Y, and next is I2. Next it reaches the Z, and finally it reaches the I3 intersection point. This is a clipped polygon. This is what the clipped polygon. Now clipping polygon is what? What is the clipping polygon here? So the clipping polygon is uh, start with A, Okay, A, B, C, D. So this is my polygon A. So let me take another color. Okay. So starts with A. A, this side will go. Okay. Because I need to reach I naught, right? So A, B, C. So first intersection point is I naught. I'm just working on clipping polygon. That is a ABCD window. I naught. Next is I3. Next is I2. Next is I1. And then D. See here, A, B, C, I naught, I3, I2, I1, D. So this is a clipped polygon and this is a clipping polygon. Now, running the algorithm. So E means entering. Okay. L is leaving. Right. So subpolygons formed. So here, first what happening? So these are all I had already written now. So now apply, run the algorithm. So starts with what? Start with I2. I2. So I2 is going to Y, and from Y to I2. Okay. So then it has to reach the, wherever the I2 here, I2. Okay. And I2 from where it is going, I1. So this is one shape, one clipping algorithm. So now run the algorithm again. So now this here. So starts with I3, I3 to V, it's going up. So V to I naught. Okay, I naught. So again it has to reach the I naught. So I naught here. So I naught to I3. Okay, I naught to I3. So this is the another clipping window. So this is what you'll got. Okay. So this is, you call it as a Wheeler Atherton Polygon clipping algorithm. Okay. So now let's work on with an example. So apply Wheeler Atherton Polygon clipping algorithm for the following polygon. So let's take, this is a polygon. So the windows are C1. Let's take points like, yeah, C1, C2, C3, C4. This is a window. C1, C2, C3, C4 are the windows. Let me take the vertex. This is a V1. Okay. This is V2, V3, V4. The vertex are V1, V2, V3, V4. Now let's take the intersection points. So what are the intersection points? Intersection points are, let's take, this is I1, this is I2, I3, I4. These are the intersection points. So now the line, it's going towards like, okay, directions. These are the directions. Let's take, these are the directions. Okay. So these are the direction. Now we have to take the clipped and clipping window, or else you can call it as a subject polygon, and another is clip polygon. Subject polygon list and clip polygon list. So what is mean by the subject polygon list? The subject polygon list consisting of the vertices with intersection point. Subject polygon means vertex with intersection point. So what are the vertex? Now start here from V1. Vertex with intersection points only you need to be right. Okay, V starts with the V1. V1. Next it is intersection point I1. Next is V4. V4. Next coming towards the intersection point is I4. Now the vertex V3. Next it's going to intersection point I3. I3 to V2. V2 to I2. I2 to V1. V1 to again V4. So this is what, like this, the subject polygon. So what I said, the subject polygon, it's nothing but it is a vertex with intersection point. Vertex with intersection point I had taken. Now the clipped polygon. Clipped polygon means clip window with intersection point. Subject means vertices with intersection point. With intersection point. That is subject. Then clipped means clip window with intersection. So now this time consider the clip window. Don't consider not vertices. Okay, we are considering the clip window, and here we are considering the vertices with intersection points, and here the clip window with intersection point. Now the clip window starts with C1. C1, it is going like this. Let's take C1, C4. So what's the first intersection point? I1. The first intersection point is I1. Next intersection point is I2. Next it is I3. Next it is I4. I4. Again it C3. C3 to C2. Again read C1. Again read C1. So now what's happening here? Now let's start the clipping. So what I have to do? Starts with I4. I'm just starting with this here. This part I4. Start with I4. Okay, this is start. Start with I4. So I4, it is like this entering. Means it is going to V3. V3 and next intersection point is I3. So whenever it reaches the I3, again it has to go to the clip polygon I3. So I3 to, again come back I3 to, not come back here, I3 to I4. This is end. Okay, this is one clipping window. See here. This is one clipping window. Now coming here, this part starts with I2, this intersection point. Starts with I2, I2 to V1, I2 to V1, V1 to I1, V1 to I1, sorry, here I1 is there. V1 to I1, okay. V1 to I1. So I1 to, again it has to reach I1, right? So this is I1. So again it has to reach I1. So I1 to I2. So this is end. This is start. So this is another clip window. So you got these two. Right along. Let's check here. So now the first one is what? The first one is you got I4. So I4, okay, V3, I3, I4. I4, V3, I3 and then I4. So the second one is starts with I2, V1, I1, I2. So this is your window and these part, whatever the clipping part. Okay. So this is a clipping part that you got. Okay. So this is the polygon ABC. Here the polygon is C1, C2, C3 is a polygon. And the one polygon is this one. This vertices is a one polygon and this is another polygon. One is a clipping polygon, another is a clipped polygon. And there is a clipped polygon. So this is how you have to apply the Wailer Atherton polygon clipping algorithm. Okay, it's simple. Let me show you again here. So what I had taken, it's a two list I had taken. So the two list is, one is subject polygon and another is clip polygon. I'm writing it clearly here so that you can make a note. Okay, start with here vertices with intersection. So V1, I1, V4, I4, V3, I3, V2, I2, V1, I1, V4. Okay, and the clip polygon C1, C4, I1, I2, I3, I4, C3, C2, C1. How you got also I said this is only you have to consider the clip window with intersection. So start any point at any point and follow the directions. Clip polygon means clip window with intersection. Subject polygon means vertices with intersection. Okay, starts with the I4. Start with the intersection point I4. So it goes to the V3 and I3. So again here it has to go with the I3 and I3 to I4. It's the end. This is one polygon. And another is starts with the I2. So go with the vertex V1 and the I1. So wherever the I1 is there in the clip window, I1 to I2. So this is the end. Okay. So this is how algorithm is working. So this is about the Wheeler Atherton Polygon clipping algorithm, students. Still, if you are facing any doubts, please let me know. Thank you.